Welcome to another episode of Zscaler Pulse, a quick 15-minute discussion on various cybersecurity and zero trust topics, as well as some Zscaler updates. Hi, I'm Ben Garrison, Program and Knowledge Manager for the Zenith community here at Zscaler. And of course, as always, I'm joined by my lovely co-host, Vanna White. Just kidding. No, Huxley Dunsany. How you doing, Huxley? It's been a little minute.
I'm good. Happy New Year. I've never felt more lovely than I do right now.
Happy. I need you to hold up the little sign for like,
Yes, exactly. Would you like to buy a vowel?
would you like to buy a vowel? Maybe I do.
Maybe.
Um, we got a whole panel of people today.
We
I don't think
do.
we've had this many people on the show before, so our challenge is going to be to keep it within 15 minutes, but we know how that goes sometimes. So, who did you wrangle up for us this time, Huxley?
Yeah, we really have an all-star cast today. So I'm going to keep it on first name basis in the interest of time here. We have our senior product manager, Shivani. We've got our senior director of product management, Eric, and our senior business development manager, Kalyan. And we are joined by a very special guest, Atul, who is the CTO over at Signal. And Atul, if I'm not mistaken, you are one of the authors of the Shared Signals Framework, and you're co-chair of the Shared Signals Working Group, which is part of the OpenID Foundation. And your bio is long and impressive, and so I won't make you sit here and listen to me read it all out, but you've really accomplished a lot with this stuff.
Thank you, and thanks for having me.
We'll
Thank you for
make sure we
joining
link the
us.
full bio in the description of the video so we
Yeah,
can make sure that he has all of his credentials broadcasted to the whole world because
yeah,
I know he's a
yeah, for sure.
very smart individual.
And with this many big brains on the podcast here, I just want to kind of get the show started with maybe a high level, obvious question for you, Atul. But, I mentioned at the start that you helped create the shared signals framework. And for, certainly not me, but for anybody else out there who's not entirely sure what that means, what would be the layman's pitch version of, well, what is the shared signals framework?
Certainly not you, Huxley. Certainly not.
No, by all means.
In short, the shared signals framework is a reliable way for delivering security events asynchronously between cooperating parties. So you can send any type of event, like let's say you suspect somebody's account is compromised, you can send what is known as a risk event for that. Or if you think that somebody's session is revoked, then you can send a CAPE event. So these are the things, collections of events on top of shared signals framework, which is why it's called the shared signals framework, because you can put multiple sort of collections of events on top of it.
That's amazing, and I can kind of read between the lines a little bit, but I can imagine there were some challenges that were pretty persistent that led to the creation of the framework. Can you speak to that a little bit?
Yeah, I think the history of the shared signals framework is very interesting. There are two streams of work that kind of combine to form the shared signals framework. Both kind of somewhat originated at Google.
Mm,
So I was working on the Beyond Corp API at Google, and I was working on the device management part of it. And it turns out that there was a situation where we wanted to be able to communicate changes about device posture and affect the sessions, and it was we were exploring different ways. And I thought this kind of way of dialing back and like calling and checking the status and all that, which was kind of the thing that was being done at that time, was a little inefficient. And that's how we started with I wrote a blog called the Continuous Access Evaluation Protocol. So,
mm.
and there was a separate stream of work in Google called risk incident sharing and coordination. So this was sort of the consumer use case where somebody's trying to compromise your Gmail account and then use that to compromise your Facebook account and your LinkedIn account and all that.
Right.
And
The
so
modern
this
nightmare.
was, trying to communicate the account related sort of security issues, whereas I was focused on the session, things in CAPE. And so we came together and we created the shared signals framework as a common asynchronous transport that can deliver all these kinds of events. And the great news is that now there is a group in the IETF in SCIM that is providing a SCIM events set of events that can be transported over SSF. So we're seeing that multiple applications develop on top of SSF.
Wow. Okay, that's awesome context. Thank you.
So part of those applications that are being developed on top of SSF, I know there's several big names out there, such as like Okta and et cetera, et cetera. But I think Zscaler, I think we're also doing some stuff with the Signals framework. I don't know, spoiler alert. I
Yeah,
didn't know,
shocking news.
shocking news here, but I think this is why we brought in Eric and Kalyan and Sravani, because how does it go from, your framework, a tool, to going into something that's within the Zscaler ecosystem, right? Into our platform and how we're utilizing it and how we're leveraging it. So maybe Eric or Kalyan, how did that relationship get started, and how did you think about, oh, let's use the Signal framework for in our ecosystem? The editor's gonna have fun with that one. I'm sure.
Yeah, I mean, I can take a quick stab at it. This is something, of course, purely done again from our product and engineering teams who discovered the full capabilities of the shared signals framework, all the events, risk, and cape, and all of that stuff, and then want to put together a sort of a big strategy around how we want to create and foster an ecosystem that can share signals in real time. And when you share these signals in real time, you can have better zero trust policy enforcement, right? So that's how we have this adaptive access engine, and we have Eric and Shravani who can speak a lot about it. But technically, if you look at it, the whole shared signals framework helps to amplify the whole zero trust story. Because in zero trust, you never trust and you always verify. You want to make sure that the policy enforcement is more consistent and coordinated, and the temporal aspect of your identity or your endpoint or your cloud asset can change like very quickly. And shared signals framework allows you to share these events in real time, and therefore the policy enforcement can happen in a more robust and a comprehensive and a coordinated manner. And that's where we sort of came together in adopting this kind of a framework in our new capability called as Adaptive Access Engine. And we have Eric and Shravani can talk more about it.
Adaptive Access Engine. Eric, for someone, again, not me, because I know everything about Zscaler. What is the Adaptive Access Engine specifically, and yeah, take it from there.
Certainly. Yeah. So I think it helps to kind of look at the problems that our customers are facing. And a lot of large organizations have a lot of different security products. And these different security products have different ways they're evaluating risk, whether it's user risk or device risk, or other even other types of security events, like a user changes a credential. Like all of these things are relevant and important, but if the systems aren't talking with each other, then it's difficult to make a really good decision of whether or not this is still the right user or the authenticated user that we've identified previously, or if they've been compromised or whatnot. So the Adaptive Access Engine is a common service within the Zscaler ecosystem. So Zscaler obviously has a number of different products, but we wanted to provide a central point where we can integrate with all of these other security products to ingest security context and also share security context. So when Zscaler determines, a user has accessed a risky website and maybe the risk profile has changed, there might be other security products that can benefit from that. And so the shared signals framework is a great solution for sort of increasing the velocity of integrations that we can build. Without a standardized protocol, we're building point-to-point integrations, and each integration that we build with a third party is a negotiation, a discussion, an evaluation, and it's difficult to accelerate that. Something like the shared signals framework being a standard allows for increased adoption, rapid adoption, and easy integration with new third parties.
I'm gonna stir the pot just a little bit. I'm gonna be an agitator. It just sounds like a really fancy alerting tool. I know it's not.
Prove me
but
wrong.
Yeah, open a sign. Prove me wrong. Because
Yeah.
I'm been an IT manager and work in the IT field, and I've hooked into alerting tools and different alerts that get sent out to do certain different things. So what's the difference between, say, an alerting tool, I won't name names of different tools, and the signals or the adaptive
Yeah.
engine?
Yeah, so that's a good question, and a key detail, the adaptive access engine that I haven't highlighted, which is not only can we ingest these signals, but then what can we do with that information? Essentially, what we provided is a way for customers to evaluate different signals, which they might have different thresholds in their environment than another customer, so they can determine, what is a risky level, what is a combination of security context that is determined to be risky. So customers can use the adaptive access engine to establish that profile. And then we publish that profile into our policy enforcement points that are evaluating access to resources. So if a user is determined to be risky based on a combination of different third-party signals, we can immediately prevent access to sensitive resources as a result of consuming that signal, profiling that identity, and enforcing the policy at our enforcement points.
Okay.
That's amazing. That's really cool. And I want to call attention to something you said right at the start when you first started speaking, Eric. This all began when we started looking at the problems customers were facing. And
Yeah,
I love
exactly.
tech history, but like Silicon Valley is littered with the graves of companies that came up with a cool technology and then went hunting for a problem to solve. And I really like that that's not what this is. This is seeing real problems in the real world and coming up with an awesome technology to address them.
Yeah, absolutely.
Atul, did you want to chime in with my previous very, very pointed question that was meant to spark conversation?
Yeah, I think that was a great observation that, it's simply an alerting tool. And in some ways you're right? Because but how do you do that, across the internet, right? You don't have a common infrastructure using which you can do alerting. Like you end up with a situation where, you have two companies and they want their products to work together and they say, oh, we have an alerting mechanism and you just have to subscribe to our API or, vice versa. The shared signals framework gives you a standardized way of doing that, right? You don't need any infrastructure, any shared infrastructure. You just need HTTP. And so this is a great way of communicating reliably, like because shared signals framework has the acknowledgements and errors and all those things built in. So you can reliably communicate events across the internet. And you don't need any shared infrastructure other than just, HTTP for this. So I think that's kind of why it works. It's also, the other thing of shared signals is it doesn't dictate policy, right? So like you say, it's an alerting mechanism, right? So a party like an identity provider might tell Zscaler that, hey, I've revoked the session, or some other party may say, oh, we don't think this device is compliant anymore. It's up to Zscaler to decide, or the Zscaler customers to decide what to do with that information. And your product can provide the flexibility because the standard itself doesn't dictate the policy.
That's right.
Then you got the profiles, and you got AI, Copilot. You have all the different things that can go into that to help with that.
Yep.
We haven't heard from Sravani. Huxley, I know you got a question for Sravani.
Yeah, I mean, thinking about all of this stuff, we've got all these signals coming in, and I'm wondering how does that actually turn into access decisions in real time with the adaptive access engine?
Yeah. So in Zscaler, Adaptive Access Engine is integrated in pretty much all the products of Zscaler, like ZIA, ZPA, major core products. And each core product can choose to perform its own access decisions. They can choose to allow block, they can also choose to step up, where they can authenticate again the user to say that this is no longer a stale session and it's a real time session. And apart from that, we also fetch signals based on different providers. Like signals that we collect from various providers are not exactly the same. Sometimes we do collect signals like credentials changed or session revoked from IDPs. Whereas if you talk about MDMs, we collect about the scores of the device, the scores on the user. So multiple other signals which customers can use and perform the actions on our Zscaler products.
You've got 2 minutes. Give me every signal that we could. I'm just kidding. I'm kidding. I'm kidding.
Pop quiz.
She's like, oh no. Give us all the signals, all of them.
That would be mean.
Oh, no.
There's a lot though, I'm assuming, right?
Yeah. We have a couple integrations. We have more than a couple integrations with our App Access engine. Like we have Defender, Okta, CrowdStrike, Silverfort. We have 4 more coming up. We have Omnisa, and there are a couple other things that we have coming up as well. So yeah, those are the integrations that we have. I won't go into directly into exact signals. It'll be a lot.
Maybe
That's
next
fair.
time. Maybe next time.
Sure.
Maybe-
We'll book a 90-minute session. You can just read down the whole list.
Exactly. That's awesome. So, okay, great. So we've got the signal framework, we got the adaptive access engine. Where does that position, and this is kind of a maybe an Eric or a Kalyan question. Where does that position Zscaler? Are we in a unique space? How does that make us, different and better for either reducing tech debt or making everything part of the platform? Where does that leave us? How does that position us in industry?
I'll take a stab at it, and probably Eric, if I miss something, you can add it as well. So the whole thing is sort of, it creates a strong connected cyber ecosystem, right? So when you're sharing signals, with the change of events that are happening, a risk event or a compliance event or some sort of a posture signal event that can come in, you're trying to create a modern zero trust architecture, where, because customers have more than one vendor that secure their cybersecurity initiatives. So you have all these signals, and when you can use shared signals framework or SSF to connect all of them, you create a modern zero trust architecture that's sort of super critical for any company's digital transformation journey. And that's what we advocate for, right? So, but Eric, yeah, if you wanted to add anything else on top of it.
Yeah, I think, you captured that pretty well. I think a key characteristic of what we're doing is really focusing on really a scalable service that allows for the adoption of these other third parties, so we can accelerate that over time and build out the integration catalog that Shravani was talking about. So I think it uniquely positions Zscaler in that we're ahead of the curve of other zero trust providers and focusing on both the consumption and the transmission of these security contexts.
Okay.
And
Again,
companies and partners love adopting an open standard such as SSF, right? So the plumbing aspect of it is sort of very well defined. It's out there. Product and engineering teams love to adopt open standards and then quickly sort of rinse, wash, and repeat and build many-to-many connectors. So soon you have a strong ecosystem that is fueling a more sort of zero trust policies in a more consistent and a coordinated way.
Yeah.
Yeah, it allows them to implement once and then scale the integrations without having to reproduce new integrations.
Yeah, no one likes to just copy and paste code all over the place, right?
Probably worth avoiding.
Probably worth avoiding. No, that's great. That's awesome. And I think this isn't going to be the last time that we hear about adaptive access engine. I know Kalyan and I have had a couple conversations about having more guests on the show to dive a little bit more deeper into the technical aspects and even the engineering behind, AAE, I guess, if we were going to throw out some acronym soup there. But this is going to continue a couple more episodes, but also, we're gearing up already. I know it doesn't seem like we should be, but we're already gearing up for Zenith Live 2026. I'm already on the phone, on the calls, gearing up for it. Registration is now open for Zenith Live 2026. So a lot of ways you can find the link to that. Go on our Zscaler webpage. I can also put the link down here in the description. And then always, of course, stay on the community at community.zscaler.com. I almost missed that one again. It's late here, okay? It's 6:50 in the afternoon, okay? I should be on that couch over there watching TV. And we'll have more information about Zenith Live. So make sure that you are attending that, because I know, and I don't want to spill it, but I'm pretty sure, if I remember all the other Zenith Lives I've been at, this is going to be something that's going to be talked about, possibly even through some labs or maybe even some breakout sessions. So if you want to learn more, get on the train now and get ready for Zenith Live 2026.
Yeah, definitely not the last time we're going to be hearing about this stuff.
Absolutely not. Cool. Right. Well, if there was anybody else have anything to say before we wrap up, I think we might have hit our 15 minutes.
We're right about there.
It felt that much. So
I just wanted to say that I'm super excited that Zscaler is wholeheartedly adopting shared signals and CAPE. When I wrote that blog, I had no idea this would become so popular. So it's really amazing to see all this development. So,
and we'll get the link to the blog too as well. So if you wouldn't mind sharing that with us, we'll make sure we get that link.
Sure, yeah. I'll share the link maybe after this call.
Yeah, you can share it with me and I'll send it to Ben.
We'll make sure it gets out there. And
awesome.
Zscaler team, I just want to say thank you all for joining. And Atul, thank you so much for joining us as our special guest star. This has been a great conversation.
Thanks for having me.